Hello again, everybody. This one's a little bit of a special request. I've had a few people reach out to me because there's a little bit of confusion about the idea of calculating out a crime rate in regards to the data that you've been provided for assignment 2. Also, I think it's important to mention that while this is part of assignment 2, you should understand that the use of a crime rate is going to be more appropriate for when we think about assignments 3 and 4 as well. So what you've got in front of you right now up on the screen is the combined data files I've provided for you for assignment 2. So on the left hand side, basically these columns here are the census data. These columns here on the right are going to be the UCR data. Now you can probably see right away that there's something sort of interesting that happens here, which is you get a whole lot of blank information. Well, that's because the census data actually provides information for the entire country, but the UCR, because of the data that we've downloaded for this, does not. So ultimately, you can leave this in here, or if you want, because it's not going to be part of your analysis, you could simply highlight this row and hit the delete button on your keyboard. And lo and behold, it's gone. We don't need to worry about it anymore. Now, in order for us to think about calculating out a crime rate, we need to understand the simple logic behind it. What is a crime rate? A crime rate is a way for us to be able to compare crime at within different areas. In other words, recognizing the fact that crime is often going to be a product of opportunity, it's to be expected that in areas where we have larger populations, we expect to have more crime, which means that we need to control for population somehow. And the crime rate is a very simple way for us to do that. And a crime rate very simply is going to be the number of crimes divided by the population, and then multiplied out by some number. Very often at the state level, we'll say 100,000. At lower levels of aggregation, we might say 10,000 or 1,000. So if we were talking about cities or even blocks, we might go to a lower number. But that allows us to compare those values and understand them in a way that makes a little bit more sense. So in SPSS, you can see with the data files you've been provided and many other data files like this, you can see that we've got a variable that is the population. And as we scroll over here to the right, you can see that we've got different types of offenses. So the very first one here, you can see we have murder and non-negligent manslaughter. And in fact, you know what? Let's just cut to the variable view because it's a little bit easier for us to look at. Let me pull this out. And you can see that our offense crimes start here. So scrolling down, you can see we've got murder, manslaughter, forcible rape, and on all the way down to getting to things like runaways, other traffic offenses, driving under the influence, drunkenness, disorderly conduct, any number of different types of crimes. Now, if I wanted to, by the way, I could talk about something like violent crime in general. That's going to require me to add a few of these columns together. If, however, I just want to focus for the moment on type of crimes that might be specific, so let's talk, for example, about burglary. So what do we know about burglary? Well, if I take a look at the variable, and this we can say it's off 030, so I'm going to scroll down here. I'm going to pull this out a little bit, and lo and behold, there's robbery off 030. Always remember, by the way, I could right mouse click, display the variable names if that makes it easier for me to work with. I'm going to go to statistics. Let's pull in our measures of central tendency, our min and max, standard deviation. I'm going to say continue. And I'm actually going to turn off the frequency tables. I don't really need to see that. And let's say OK. Now, note that we have 50 valid cases and one missing. One of the states actually didn't provide data. And you can probably look through, you'll see a bunch of negative 99s for one of the states. And that's the missing one. You can see on the average, the states had about 1,600 robberies. That's per state on the average, so multiply that out by 50 to get an approximate for the country. The minimum of 19, so we had a state that reported only 19 robberies in a year. And then the maximum, you can see that we had a state here that ultimately had 15,880 robberies within the year, which is obviously a pretty big range here in terms of those values. So it's important then for us to think about how that may be affected by the population. So I'm going to close this. And I'm going to go over here to the top. And you can see here that we have our compute variable. And remember, the compute variable is about us creating a new variable. And that's exactly what we're doing. We're computing a new variable based on an old variable or variables. So I'm going to go compute variable, and I'm going to give this a new name. I'm going to call this the robbery rate. And I'm going to say, just like we talked about a moment ago, I'm going to say robbery divided by population. Now, I'm going to go a step further here, and I'm going to put this in brackets. And by the way, the other option I had here, I typed that in by hand. Here's another option I have, which is I could have clicked the brackets button here on the screen, and then basically said robbery divided by population. And then, as you might recall, the last thing I said is we usually multiply this out by a larger value. In this case, 100,000. And remember not to put a comma in because it's just going to confuse the program. Once I do this, I'm going to say OK. You can see the program output reports back exactly what I did. New variable of robbery is equal to the number of offenses for robbery divided by the population multiplied by 100,000. If I minimize that, I can come down here and lo and behold, I have a new variable called robbery rate. If I switch over to data view, I could scroll all the way to the right and I can see those robbery rates. Now, the interesting thing about this is these numbers are actually, pretty close to each other in a lot of ways, not that large difference we saw a minute ago of 19 versus 16,000. So let's actually even take a minute here to pull in that robbery rate variable, and I'm going to leave the original robbery variable here. So this is counts and this is rates. Let's say OK. And so what you can see here is that while the average number of robberies was about 1,600, that ends up being about 22 robberies per 100,000 people in the population. The low is about 3 robberies per 100,000 people in the population versus 65 per 100,000 in the population being the maximum. So you can see right away that difference changes quite a bit. Now you might say, how do we end up with 3 when there are only 19? Well, it's because ultimately we're dividing that 19 by the population, then multiplying it out. Now, this multiplying out by 100,000 is really for convenience sake, because it allows us then to talk about per 100,000 in the population, which ultimately is a little bit easier than if we didn't have that. And let me just show you this one last thing, and then I'll stop. But I'm going to go here, I'm going to say transform the compute variable. I'm going to call this robbery rate 2. And I'm actually just going to take that 100,000 out so we can see what ends up happening. And then say OK. Now, when we go here to this robbery rate, you see it's all zeros. It's not really zeros. In SPSS, the default is to only have 2 decimal places. If I switch over to the the variable view, if I actually go over here, you can see decimals, new robbery rate 2, and I'm going to give this a few more. I'm going to tell it to do 8. It actually doesn't like that because it's trying to keep the size here a little bit smaller. So let's instead, well, that was a mistake on my part, I apologize. Let's see if it'll let me just do 6 easily. That should do it. I'm going to go to data view. And this is what we get. Now notice that you can see, looking at the column on the left-hand side, robbery rate, versus the column on the right-hand side of robbery rate 2, the numbers are really the same. The difference is just that cutting out of the 100,000 multiplication at the end for the second one. And again, what I was saying before, the logic here is pretty simple for why we multiply it by 100,000. For the robbery rate, I would say we have 27.7 robberies per 100,000 people in the population. On the right-hand side, with robbery rate 2, I would say we have 0.000277 robberies per person, which doesn't really flow off the tongue, both in terms of talking about it and, for that matter, making it easy for us to understand. That first one, that robbery rate per 100,000, I think makes a little bit more sense and is really the more common way we demonstrate and report this information out. All right, so again, this was in response to a few questions that people were raising. I hope you all found this helpful. Have a great day.